This media is brought to you by Polyscope.
In the realm of tomorrow, where techniques mind, we ponder, we dream.
Ready?
Yep.
Well, thank you so much for coming on the show. It's great to finally meet you because this is how we meet each other nowadays over Zoom. So why don't you tell us a little bit about yourself and your organization and what you're passionate about?
Yeah, so my name's Helen Gu. I'm the founder and CEO for InsightFinder. I've been a kind of a research scientist in computer science field for past 20 years. And so my
Wow.
research is about quality of service for distributed systems. So my passion is about the reliability, right? So I think, we all rely on IT system nowadays, and more than ever. And so we actually rely on IT systems to deliver critical messages and to actually help us to finish tasks that can be life, also some, like surgeries, right? So it's all those things basically requires the IT systems to be highly reliable. And so that's basically my passion. And so in the past 20 years, I have been doing research in this field and leveraging basically AI technologies. And so interestingly, before AI becomes like a mainstream applications topics nowadays, and so we have been actually looking at how to use the AI technologies to make our computer systems more reliable. And nowadays, basically, a lot of more people rely on AI systems to actually make their daily life easier and better. And so we basically uh, excited to see is that with the AI technology we developed in the past and can help customers even to make their AI systems applications more reliable and more responsible and more accountable, right? So that's basically what InsightFinder does nowadays. And so to provide this AI-driven IT observability and AI observability tools to our customers.
So when you talk about reliability, what kind of systems are you talking about? What do you mean by reliability? Because a lot of times I think that I see systems out there and from the outside, everything looks really nice and smooth and wonderful, but
Yeah.
underneath it's cobbled together. A whole bunch of different things are cobbled together. So once you go under the covers, there's a lot of things that could go wrong. So what do you mean by reliability?
Yeah, so it's interesting, right? So I teach digital systems in my class, like, over past 18 years. And so one of the things for distributed system, right? So like, for example, we are having a Zoom call. That's a distributed application. And so you probably don't notice basically some of the packets got lost when we have this conversation. You probably don't know some servers actually went down or some network got congested during this conversation because everything is actually encapsulated by the distributed system. And so that's a nice thing about distributed system, but that's also the reason why it's so hard actually to make sure this distributed system is highly reliable. Because when something goes wrong, when this video streaming stopped, and anywhere could be possible has become the
Yeah,
root cause.
you don't know where the problem is. I mean, that's the problem, right?
Yeah, exactly. So you might get a million alerts and at the same time, and you don't know where to start from. So that's basically what Insight Finder trying to help here is to actually surface the root cause by using basically AI technology, right? So, if we have just one or two servers and we want to debugging, right? So at the early days, for example, Oracle database is a very commonly used distributed database, right? And
Mhm.
we have even a profession like a DBA to supervise the system, but still, it can be done by human, right? So because you just have a few nodes to manage. But now basically, if you look at the cloud, if you look at all those AI systems, they run on like millions of machines, right? And they cover so many hardwares across the region. And so when something happened, and so it's going to be actually very challenging for human to do that. And also, most of the time it's mission impossible because like, we are not good at actually really to understand the intrinsic relationships when we look at the time series data, for example. And we are not well, our brain is now trained to look at the distributions of the data, right? So if I ask you, okay, CPU is higher than 50%, is that good or bad? Maybe you can actually make a very clear judgment based on the knowledge. But if I give you two time series, ask you, is there any distribution changes? Without any tools, it's going to be hard. Yeah.
Right, absolutely. So one of the things I like to say when in that simple scenario, when software first started, it was sort of client server. You had one database, you had a front end, and it was very simple. It wasn't distributed. But nowadays, if you think about sort of like a typical site like Kayak, like a typical travel site, and from the front end, it looks pretty simplistic, but the back end must use thousands of APIs connecting to thousands of different servers and thousands of different places. And all of these things have to work together in concert. It just gets ridiculously complicated. Even the simplest applications, even microsas and stuff like that, they use 5, 6, 7, 8 plus APIs. And I'm assuming that you're able to detect issues in any of those.
Yeah, that's exactly the point. Basically, because we use algorithms, particular unsupervised machine learning algorithms, to actually analyze massive amount of data and also doing analysis in a kind of like, concurrent way and holistic way. Instead of looking at the individual nodes, individual network links, we look at everything at the same time.
Mm.
And so basically, you can actually paint the picture and how this problems propagates, right? So what is the causal chain look like in your large scale distributed systems, right? Even like you mentioned, right? So even a simple website like Kayak, they can actually go through like, thousands of APIs, many millions of nodes. And so where the problem come from is basically important to know the source of those causal chains, right? So that's basically what algorithm can help discover. And then that's basically where the time consuming part. And when the reliability is actually at risk, that's the reason, right? That's the reason is that the system becomes so complex and the system also becomes so interconnected, right? And so that's a reason. Yeah.
Well, don't you need a ton of data to be able to do that? So how do you gather all that information? Because like I said, you have thousands of APIs, you get millions of nodes. How do you gather all that data to be able to analyze it?
Right. So in the past, I would say like 10 years, I think a monitoring system has really become uh, mature, right? So there's a
Mm,
lot of techniques actually talking about the data collection, how to do things like more scalable way, and how to store the data, how to actually query the data, and you can get those data in a timely fashion. So I think the whole industry also become more standardized. There's a open source tools like open telemetry and everybody embrace that, right? So we have a standard format, and so whatever system you are building, if you actually follow open telemetry, you can generate monitoring data and you can actually compare and analyze with any other monitoring data because they are all follow the same format. So I would say like that's a big improvement in our IT management, IT operation space. But what is the challenge here is that we keep hearing, right? So as those monitoring tools actually become more and more powerful, we are collecting lots of data, right? So we are actually overloaded by this many monitoring data. Even we can collect all those data and put this data in the storage. And if we don't have a right technology to actually understand the data, and it's basically a waste of money, right? And
mm.
so and to a lot of our customers, they have to actually pay a very high cost to maintain this monitoring infrastructure, and paying the third party like Datadog to do that, or basically you have to build this very gigantic open source infrastructure and maintain the infrastructure by yourself as well. And either way, it's very expensive, right? But we're still seeing so many production outages, right? And we
Oh yeah.
still see a lot of problems. The reason is that the data, if it's useless, unless you can translate them into kind of actionable insights,
Right.
right? So for the operators to react to act upon. Yeah.
Right. Well, I think that's exactly what's happening is that everybody's collecting everything. They're collecting every possible thing,
Right.
which means they're collecting more data than actually is useful, right? And unless you have some way of looking at the data and monitoring the data and getting insights out of the data, there's no point to it. And
Right.
I think what ends up happening is that people just feel like they can't do anything with it because there's just so much of it, and there's no way they can handle it.
Yeah, yeah. I think that the problem is that so a lot of people because they don't know so it reminds me early days of a cloud computing, right? So when people use cloud computing, they don't know how much resource they need. So they
Mm,
basically over provisioning, right? So they purchase a lot of machines and they just like hope basically the peak workload is not got like violated by the resource constraint and so but they are paying very high cost for doing that
oh yeah,
and similar problem here and because reliability is so important and a lot of people just think okay we just collect all the data and in case something wrong we can go back to check, right? So it's more kind of insurance, but the problem is that if you don't know how to look at the data or basically a lot of things is that if you look at it too late, it's again it's basically not going to be very effective and at the same time you are paying very high cost for it. Yeah.
exactly. I mean, you really need to be able to look at the data in near real time and to be able to make insights out of the data from in real time. And then you can
Right.
discard, like once you've got the insights, do you really need to keep all that data?
Exactly,
Yeah.
exactly. Yeah. So timing, I think, is more important than data at this point, for these kind of problems, right? And so, and also, we, as a computer scientist for this in this field for 20 years, and I always tell people, a lot of distributed systems, they are building with many replication mechanisms, and they have built-in basic fault tolerance in it.
Mm,
So the thing is that it's the as a result, the basic distributed system doesn't break just like that, right? So it never have the production crash. It's a simple like sudden crash. It always start from some small problems and then propagates in your systems. So because of that, because it's so complex and highly redundant, which means you do have lots of opportunities to actually prevent those big outages down the road, right? So we have seen so many times with our customers. And so if we actually notice this issue early on, and a lot of times the symptoms, actually the problems, root cause manifest like 24 hours or 40 hours
mm,
ahead of the real outage. And
right.
so that's why timing is so important. If you catch that early on, it's really easy problem to fix. And so I work with one customer outage and they have the huge like company-wide site down. And so it actually caused by a few kind of database nodes actually have the disk issue and so kind of like disk full or some aging hardware. And so they notice the problem, but they don't know if they don't fix the problem fast enough, right? They are waiting to order a new disk and to replace that. But the big outage happened before that new disk arrived. And so that's basically because people don't know the impact, right? So they don't know even right now it's just a few disk failures, but it will cause a big, your site outage. And then people will know, okay, I need to take some actions now, right? So I need to actually either reduce my workload or basically, do some operations to actually expedite the disk usage or basically at least let customer know also, right?
Mm,
So then instead of like, had the company-wide site down for like several days, and also lose customer data. Yeah.
yeah. So are you able to, is this pre-AI or before it pre-AI, were you able to detect these things or you needed AI to be able to detect those kinds of failures?
Yeah, that's interesting. I actually start to use AI technology like almost 20 years ago.
Oh no,
Um,
no, it was only invented last year, right?
yeah,
It's only
I
been it's
know.
only 2 years old.
Yeah, I know. It's a so neural network, all those technology are like, 50, 40 years old.
Yeah,
And so
exactly.
people talk about this technology for a long time. And so I think the key thing like for me is that um, because of the scale we're looking at, right? So even basically traditionally people look at, simple solution, for example, like, rule-based approach, right?
Yeah.
And also like some researchers look at control theory
Hmm.
to adjusting basically systems based on the failures or something like that. And so the problem with those approaches is, as you can imagine, right? So if I have like so many nodes, so many APIs, how do I set thresholds? How do I set policies? And how do I set rules, right? That's not going to be scalable if you have, so many complex systems. And especially today, we have systems actually composed of many components, and also some of those are third-party components. You don't know, right? So when you use
Yeah,
ChatGPT, and if ChatGPT gave you an answer and that triggers certain processing in your system and then bring your system down, and so you don't know, right? So you don't have that policy or rules to cover that case, right? So
exactly.
so that's basically the things that we think you have to actually let the data to tell you the information, right? So there are a lot of insights and signals are buried in that massive amount of monitoring data we are collecting. And so the key thing is that how to extract those insights and important information out of this massive data in a very timely way, right? So, and
Mm.
also in a cheap way, right? So rather than basically you have to hire, army of data scientists to do that, you want a computer to do that for you, right? And in a very effective and timely way. So that's where the AI technology is important. So that's why, I have been doing research in this field for a long time. And so even though early days, like we look at the supervised machine learning, and we basically trying to mimic human behavior and
Hmm.
knowledge, but then we realize this approach is not very effective because if you use just like supervised learning, and so you have limited knowledge, right?
Yeah.
And in particular, if you look at a lot of issues and problems, they are unknown, right? They didn't happen before.
Oh
And
yeah.
so how do you tackle those problems using supervised machine learning or mimic human behavior? So that's basically why we actually have laser focus on unsupervised machine learning. How do we actually effectively identify and diagnose unknown problems and just based on the data, right? And so we're trying to discover the relationships, the anomalies, the root cause just by purely looking at the data. Of course, like there's ways for human to put in to provide the input, but we want the AI algorithm to be the main driver, right? So the AI algorithms will actually surface the most important information, and then human can really make the accurate decision based on this limited amount of the important information, rather than like human to search the important information out of massive noisy data and then make a decision. That approach is not going to be scalable, and it's proven to be broken. Yeah.
Right. But you do have to give it some training data though, so it knows what's a failure and what isn't a failure, right? I mean, there's got to be some supervised learning there as well. No?
Yeah, you need a training, right? So machine
Mm.
learning is about learning, right? So and particularly we are doing online learning, which means we are not just learning one particular failure. We are learning all the time. And also, so for unsupervised machine learning, the key thing is not really learning failure. The key thing is also most important thing is learning what's normal, right? What's the
Mm.
normal behavior look like? And then you can detect any like deviations, right? So either it's a recurrent failure pattern, then you can recognize, or basically it's a new pattern, right? And so you can tell the operator, okay, this is a new anomaly we never seen before, and also give basically the reason why this is an anomaly. And what's the composition of this anomaly symptom, and that becomes basically the root cause, right? So what's the root cause that basically caused this problem? And so all those information will be very useful for the human to actually make the right decision to recover system. Yeah.
So that way it's kind of like you're looking at your bill. right? You look at your bill every month, your phone
Mhm.
bill every month it's the same, it's the same, it's the same, and then one
Right.
month it's like $10 more or $5 less, and you're like, okay, there's an anomaly there. Let's investigate it. But you're saying the AI looks for the anomalies and it can also investigate the anomaly at the same time?
Exactly. Yeah. So basically, so just a great example of the phone bill, right? So if you look at the bill and then it jumps and basically will give you the details, right? So like break down what calls you made, where it's from, what's the source, and then basically you can use that to actually attribute what's the root cause, right? That's
Right.
exactly what we InsightFinder AI does, and then we look at all the data, and we also look at also your data, like for very long history, right, including your holiday season, your typical, like kind of like different operation and a different time period. And then we can identify the anomalies and then analyze among all those data, right? So what's basically attributes to the current problems you are having. And so this is not only help the current diagnosis, but also can learn, okay, what are the early symptoms, right? So for example, like I mentioned, production distributed system never crash just like suddenly. They always have some early symptoms, right? That's an opportunity for us to be proactive and to actually predict the issue early on. So that's what we're looking for. And we can actually use the algorithms to actually learn this knowledge. And rather than basically you can imagine is that you put down a rule manually saying, oh, if CPU spikes to over 90%, my service will go down. And so the AI algorithm will automatically learn that. And they can
Right.
learn like millions of those rules, right?
So how long have you been around as a company?
Yeah, so InsightFinder is actually founded in 2016, and so we started in 2016. So this is actually ninth year for InsightFinder,
Wow,
and
congratulations. A lot of startups don't last that long.
I know it's a long journey, but we are very proud that we have been helping some of the largest companies in the world to maintain their critical infrastructure, and so those are basically important, I think, for our human society. And so we have been working diligently with our customers to tackle this hard problem. And this is a very difficult problems, right?
Hmm.
Even like in the research field. So I have been doing research in this field for 20 years now. And so even in academia, so I chaired some of the conferences, right? So there's academic conferences focused on using machine learning, doing system management for like 15, 18 years already. So this is a known hard problem, right? And but how to tackle this problem with like a practical solution, that's the challenge, right? So like there's a lot of machine learning technology being developed, and but so most of those algorithms have actually wrong assumption about the machine data. So
Mm.
it's very hard to apply, right? So that's why some of the products on the market, right? So they say, okay, we give you these algorithms, you pick the algorithm you want and you build it yourself, right? And so that's basically the problem is that most of those off-the-shelf algorithms is not suitable for the machine data we need to analyze, right?
Right.
And basically the it takes experience and time to actually really to understand what's the need. And so like I told many people like many times is that you cannot actually fit algorithm um fit the data to your algorithm, right? So you cannot say, okay, data doesn't work, so my algorithm is perfect, and you change your data, right? No, in the real world, data is noisy, data is fluctuating, and
Oh
that's
yeah.
something you cannot change. So what you can change is, change your algorithm and make
Hmm.
sure your algorithm can serve the data. Yeah.
Yeah. Yeah, absolutely right. So it's time to think like a futurist. It's the year 2035, 10 years from now. Where do you see your company? Where do you see the world? Where do you see technology being in 10 years?
Yeah, so our mission is to become the brain behind every IT and AI infrastructure, right? So
Hmm.
we want every IT and AI infrastructures can run smoothly without glitches. And so that's also a personal. I have a personal wish on this because my husband actually is an engineer and he needs to actually maintain their production website. And he was called away, during the middle of night and on Thanksgiving dinner, and he has to
Oh
be
no,
he
that's
has to leave.
terrible.
It happens to us all the time, and
Yeah,
so
I believe it.
um, so we so I hope basically those systems can run smoothly and reliably, and also give time and life back to our heroes, and they can actually really help us to make the system better, right? So in many different ways, rather than just keep troubleshooting and doing patching all the time.
Yeah.
I think in 2035, I think like, we all seeing the IT computers and the IT system become part of our professional life, right? So like, whether we're doing any business, we are relying on IT. But then 10 years later, I think IT system will become even more integrated into our everyday life.
Mm.
I think, so in the future, for example, if as we're aging, right? So like, in our home that we should have robots to actually take care of us in the sense that if we fell down, right? So like elderly person, I heard many times, right, when they fell down with their alone and, sometimes their lives could be saved if there's
Hmm.
somebody's there, right? And so basically, I think the IT like robots, computers can do those things, right? So they can detect those problems and send notification to a doctor, and then the people lives can be saved, right? And so in a similar thing, education. I think education will have a lot of changes with this AI technology, right? I'm seeing like my son is actually using ChatGPT to learn a lot of things nowadays. So
As long as
it
he's not using it to write any papers, right?
that's right. Yeah. So we make it a very clear rule is that no assignments on ChatGPT.
Yeah.
And so that's also my rule for my class students. Yeah.
Mhm.
But I think it has benefit, right? So it has benefit for you to actually be able to learn different knowledges quickly. And also I think in other ways to basically for us to change our lives, right? So basically more convenient, more efficient. I believe the IT system will become more integrated. That's what we believe is that it's more than ever, it's important to ensure the reliability and accountability of our IT systems because it will be impacting everyone's life and sometimes could be life threatening. Yeah.
Oh yeah, and the thing is that people who are outside of IT don't understand how bad things could be underneath this beautiful surface. So you're working on a beautiful application and you think it's great, but underneath it all is sort of, thousands of APIs all cobbled together. And, one small mistake and you're spending 23 hours in Zurich that you didn't need to when you're doing your travel bookings.
Exactly. That's right. That's exactly right. So yeah, well said. I think that's basically what we hope to achieve and help our customers to excel as well. Yeah.
Fantastic. Well, this has been great. Thank you so much. If somebody wants to get in touch with you, what's the best way?
Yeah, so basically you can go to insightfinder.com and to actually check out our information. And also so feel free to email me if you actually have questions, and you can email to info@insightfinder.com. So we'll basically help, answer any questions you might have.
Awesome. Well, thank you so much. This has been great. Thank you.
Thank you. Yeah. All right.
Bye.
Have a good day. Bye.
Bye.
Pixels and philosophies merge and mold, a future untold, unseen.